This is the predicted paper that I have put together for 2025. It's for the non-calculator paper, specifically for Edexcel, and it's all the topics that I just think are likely to come up for the non-calculator paper, things that we normally see on this paper, with a few other topics mixed in. I really hope you enjoy it. Question number 1, we are asked to change 20 centimetres into millimetres. So we know that 1 centimetre is equal to 10 millimetres. And therefore, if we're going from centimetres into millimetres, we are going to be multiplying by 10. If we were going from millimetres back to centimetres, we would be dividing by 10. So here, 20 centimetres into millimetres, let's do 20 multiplied by 10, and that would be 200. For question number 2, write the following numbers in order of size. Start with the smallest number. So here we have percentages, decimals and fractions. And this question is going to be a lot easier if we can convert them to be the same format. So all as percentages or all as decimals, probably not all as fractions because that might be a little bit confusing if the denominators are different. So let's go here with decimals or percentages. So 20%, let's keep it percentage, 20%, 0.3. If I want to go from decimal to percentage, I'm going to multiply it by 100. So that would be 30%. 0.23 is 23%, and a quarter, if I want to make it out of 100, which would enable me to get it as a percentage, I need to multiply the denominator by 25 and also multiply the numerator by 25. So a quarter is the same as 25 out of 100, which is 25%. And now it becomes a little bit easier to order them. I'm going to go with 20% first, then 23%, so let's put 0.23, then 25%, so then let's put a quarter, and then 0.3, which was our 30%, is the biggest. Question number 3, work out 30, add 5 multiplied by 2. So for this question, we need to make sure we're thinking about BibMaths. Now, BibMaths really should be written like this. Division and multiplication are as important as each other. Same with add and subtract. So if both of those operations were to come up, we would just work from left to right. Here we have add and we have multiply. So we're going to make sure we do the multiplication first. So this is 30, add, and 5 times 2 is 10. So 30 add 10 gives me an answer of 40 for that one. Question number 4, write 5.28 correct to 1 decimal place. 1 decimal place means 1 number after the decimal point. We're then going to chop there, check the next number. So because it's an 8, 5 and above rounds up. So that 8 tells me to round the 2 up to a 3. So 5.3 would be our answer there. Question number 5, write down the value of the 5 in the number 7,852. Now the most common mistake I see on this one is students writing tens, and that would not get you the mark, okay? So we need to say the value of the 5. Yes, it is in the tens column, but you would need to say it's worth 5 tens if you wanted to get the mark, but I would probably just put 50. That would be the best answer there. It's what it's worth. Because it's in that column, it's worth 50, so 50 is my answer for that one. If I asked you for the value of the 8, we would say 800 or 800s. That's how much it's worth because of the column it is in. Question number 6, here is a list of numbers. From the list, write down a factor of 20. So factors are numbers that fit in an exact number of times. So 1 and 20, 2 and 10, 4 and 5. These are all factors of 20 because they fit in an exact number of times. So 1, 2, 4, 5, 10 and 20 are all my factors of 20. We're looking for one from the list though, so 5 makes sense here as my factor of 20. We're next asked for a prime number, and a prime number is a number that can only be divided by 1 and itself to give a whole number answer. It's got 2 factors, 1 and itself. So looking at that list, 5 is a prime number, so we can have that one again. In fact, yeah, we could have 5 again. I'm not going to though, because there is another one. 12 is an even number. It's in the 2 times table, so that's not prime. 15 isn't prime. It has a factor of 3. It has a factor of 5. That's no good. 27 is in the 3 times table, so that's no good. 29 is not in any times table other than the 1 times table and the 29 times table. 29 is a prime number. And in fact, Edexcel really commonly ask you for prime numbers in the 20s. So it's really good to know that 23 and 29 are your prime numbers in the 20s. 40 wasn't prime because it can be divided by 10, 4, 20, and so on. Okay, and then part C asks for a cube number. And a cube number is the answer when you do 1 times 1 times 1. So that's 1. 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 3 times 3 times 3. So 3 times 3 is 9, times by 3 is 27. And it's this answer that is your cube number. So 1, 8, 27. The next one is 4 times 4 times 4, which is 64. And 5 times 5 times 5, which is 125. But here we're looking for the number 27 is our cube number from that list. So you could have had 5 there, or 29 and 27 for that one. Okay, question number 7. Write down the mathematical name of this quadrilateral. What is it called? So this one is like a pushed over rectangle. This is called a parallelogram. Don't worry about spelling. As long as we know what you mean, it's all good. Parallelogram there. So let's just recap. If all 4 sides were the same length, that would be called a rhombus. If it was a pushed over square, that would be a rhombus. You will probably know that this one or this one, these are both examples of trapeziums. Oh, and this one is a kite. So they're all really good ones to know. Write down the mathematical name of this 3D shape. This is a sphere. So not to be confused with a cylinder. A cylinder is like your can of baked beans. So that one is a cylinder. This one is a square-based pyramid. And we could also have a triangular-based pyramid and things like that. So they're all really good things to know. Oh, while we're on that topic, now I did think about maybe doing parts of circles in this question. Again, that comes up quite often. So maybe let's just zoom in here so I can do a lovely little drawing for you. So if I had a circle, the line from the center to the edge, that's the radius. If you go all the way through from one side to the other, that's called the diameter. And if you had a line that just touched the edge and carried on, that's called a tangent. Now this area here, that's a sector. And if you had a line that went over, that would be a chord, and the area it makes is a segment. So they're all really good things to know if you are asked about circles as well. Okay, next question. Question number 8. Simplify 2a times 7b. So because we're multiplying, we don't need to worry about the fact that these are not like terms. We can just smush it all together. So 2 times 7 is 14ab. And we would just say that we're multiplying it together, so we would write it all next to each other. Let me go back to this. So 14ab over here. Now with part B, we do need to worry about our like terms. We're adding and subtracting, so we can only collect together like terms here. Let's have a look at the x's first. So I've got 4x, add 3x, minus x. So altogether, 4 add 3 is 7x. Take away, now the x on its own is the same as it being 1x. So 4x add 3x is 7x. Take away 1x is 6x. There we go. And then if I look at the y's, I've got minus 2y, minus 8y. If you are at minus 2 on the number line and you take away 8 more, you are going more into the negative. So that's going to be minus 10y that we get to. So that one, 6x minus 10y. Now, last but not least, if you've been on my Sunday sessions, you will know that for this one, p squared add p squared add p squared, I test you on this one a lot because a lot of students go wrong here. So this is adding. So the powers are not going to increase. If I gave you p squared times p squared times p squared, that would be p to the power of 6 because you're multiplying. So you're doing p times p times p times p times p times p. But here we are adding, not multiplying. So we need to make sure that we just collect them up. How many p squareds have you got? I've got 1 p squared, I've got another p squared, I've got a third p squared. So this is 3 p squared. Very tricky, that one. So well done if you got that one right. Question number 9. The pictogram shows information about the number of bicycles sold in a shop on Monday and on Tuesday. Over the 4 days shown, the shop sold a total of 56 bicycles. 2/7 of these bikes were sold on Thursday. use this information to complete the pictogram. So we need to do 2/7 of 56. And to do a fraction of an amount, we divide by the bottom and then multiply that answer by the top. Now, it is so important to me that we revise this. This is one of the most common skills I see throughout the foundation papers, fraction of a number. Divide by the bottom, multiply by the top. So 56 divided by 7 is 8. You're then going to take that 8 and multiply it by 2. So 8 times 2 is 16. So we therefore know that Thursday needs to be 16. And then the rest of the bicycles must be on Wednesday. So let's work out what Monday is representing. We know that a full circle is 8 bikes, which means that a semicircle like that would be 4 bikes. And a quarter of a circle would be a quarter of 8, so 2 bikes. So when I see this on Monday, I've got 8 for the full circle, and then I've got 4 and 2, so this is 6. 3/4 of 8 is 6, so that one is 14. I then on Tuesday have 8 and 4, so that is 12. Let's add together the values that we've got so far. So 14, add 12, add 16. That is 42. And then I'm left with the rest. So I know that 56 bicycles were sold in total. 56, take away 42, leaves me with 14. So I then need to draw 14 on Wednesday and draw 16 on Thursday. 16 is okay, that's just 2 full circles, 8 and 8. And 14, we already know what that looks like from at the top. It's going to be 1 full circle, which is 8, and then 3/4 like that, which is 6. Do not draw the 3/4 separately. So don't do like one of these and one of these. It needs to be a continuous shape. So make sure that it looks like that, kind of like Pac-Man. There we go. That's 3 marks for that one. Question number 10. An ordinary fair dice is thrown once. On the probability scale, mark with a cross the probability that the dice lands on a multiple of 2. So multiples are numbers in that times table. So multiples of 2 would be 2, 4, 6, 8, 10, 12. But obviously I'm rolling a dice here. We know that only goes up to 6. So I need to think about the probability of rolling a 2, a 4 or a 6. That's 3 different options out of the 6 options altogether. So my probability is 3 out of 6, which is a half. And either way, we would be putting a cross there at a half. Question number 11. ACD is a straight line. Work out the size of angle ABC. So when we say ABC, I need you to imagine that you're walking from A to B to C. And the angle that is made, that's what we're trying to work out up here. So this is my X, that's what we're trying to calculate. What do we know so far? So this line here and this line here mean that those 2 sides are equal in length, which means it's an isosceles triangle. So if this angle is 23 degrees, then this angle up here is also 23 degrees. And that then enables me to work out all of the other angles. There are a couple of things you could do here. So I can actually at this point have a look at the full triangle ABD, and I can see that I've got 64 degrees here, I've got 23 degrees down here, I've got 23 degrees here, so X is actually what's left to make the big outside triangle add up to 180. We know angles in a triangle add up to 180. So if I do 64, add 23, add 23, that's going to be 7, 8, 9, 10, 0, carry the 1, 6, 7, 8, 9, 10, 11, 110. I'm then going to take 180, take away the 110, and we're left with 70. So my answer here is 70 degrees. However, you might not have done it that way. You might have then said, well, actually, let's have a look at this triangle over here on the right. If I know that it's isosceles, I've got 23 and 23, then the angle that's missing here is going to add with those 2 23s to make 180. 23 add 23 is 46. 180 take away 46. Now here we've got more on the floor. Let's borrow from next door. 10 take 6 is 4. 7 take 4 is 3. And then we just have a 1 there. So 134 degrees for that one. Then this one, because they're on a straight line, needs to add up to 180. So 134, we know that 46 needs to add with that to make 180. Now all we need to do is have a look at the triangle here, ABC. I know that 64 add 46 is 110. And so again, we're left with that angle at the top being 70 degrees because angles in a triangle add up to 180. So slightly longer, but again, really good to practice those skills. Either way, knowing that x is 70 would be the correct answer there for 2 marks. Question number 12, and we have coordinates. Write down the coordinates of the point A. So we need to remember when we do coordinates, it is along the corridor, up or down the stairs. So to get to A, imagine you're starting at the origin. We're going across to -1 and we're going down to -3. So that is the point -1, -3. There. It then says on the grid, mark with a cross the point 2, 0, label this point B. So 2, 0 is going to be 2 across, and then we are not going to go up or down. The y coordinate is 0, so it's going to stay at 0 and not lift up or go down. So that there is your coordinate B. Then it says, draw the line with equation x equals 3. Now here is where students will start to go wrong. We need to draw a line here. X equals 3 is the line where all of the x coordinates are 3. And it looks like this. So it goes through 3 on the x-axis. Now, a lot of students get that wrong because the x-axis is this one, which goes that way. But the line x equals 3 is not that way, it's this way. It goes through 3 on the x-axis. So x equals 3 looks like that. X equals -2, for example, would be there. X equals -5, for example, would be there. So x equals is always going to be a vertical line. If I asked you for the line y equals 2 would be the line that goes through 2 on the y-axis. So y equals a number, goes horizontally like that. X equals a number, goes vertically like that. For this question, we had to draw x equals 3. Let me label that on there. You didn't have to label it, but x equals 3 would look like that, going through the x-axis at 3. Question number 13. A rectangle has an area of 10 meters squared. Find the perimeter of the rectangle. So we need length, add width, add length, add width. We need to go all the way around the outside if we want the perimeter. And at the minute, I only know how long this side is. I don't know how long this side is, but we can work it out because we have the area and we know that base times height equals the area. So area equals base times height. And so we need to do 10, which is the area, divided by 2 2/3 in order to get how wide this shape is. So I'm going to start with that. 10, oh, it's behind my head. 10 divided by 2 2/3. When we divide fractions, we keep, change, flip, we do the reciprocal, we divide. Dividing by a fraction is the same as multiplying by its reciprocal. So first we need to make this an improper fraction and make it top heavy. So to do that, big times bottom, add on the top. 2 times 3 is 6, add the 2 is 8. So this is the same as saying 10 divided by 8/3. And you might feel more comfortable making it 10 over 1. Instead of dividing by 8/3, we're going to say that's the same as 10 over 1 multiplied by 3 over 8. Dividing by a fraction is the same as multiplying by its reciprocal. So dividing by 8 over 3 is the same as multiplying by 3 over 8. The reciprocal is when you invert that fraction, or if it was 5, it would become 1 over 5, for example. So there we go. Let's multiply that together. This is 30 over 8, which is 8 into 30 goes 8, 16, 24, 3 times, with 6 left over out of 8, which is the same as 3 3/4 if we simplify the 6 over 8, because they're both in the 2 times table. So we now know that the width is 3 3/4. We now just need to work out the perimeter. So here what I'm going to do is add 2 2/3 with 3 3/4, and then I'm going to double my answer afterwards because I know that the perimeter is this, add this, add this, add this. But rather than add 4 fractions together, I'm just going to add those 2 and then I'm going to double my answer because I know that that will get me the rest of the way round if I only want to add those together. So let's do that. 2 and 2/3, add 3 and 3/4. And again, we want to make these top heavy. So 2 times 3 is 6, add the 2 is 8/3, add 3 times 4 is 12, add the 3 is 15/4. Now to add fractions, we have to make the denominators the same. Adding and subtracting fractions, you want to make the denominators the same. For multiplying, we just do numerator times numerator, denominator times denominator. But for adding and subtracting, we have to make them the same. So I'm looking for a number that's in the 3 times table and the 4 times table, and that is going to be 12. Whatever you've multiplied the denominator by, you need to also multiply the numerator by to keep it equivalent. So with 3, we multiplied it by 4 to make it 12. So I also need to multiply the 8 by 4, and that is 32. With the second fraction, I've multiplied the denominator by 3, so I also need to multiply the numerator by 3, and that is 45. Altogether, I have 77/12, and that goes in 6 times, because that's 72, with a remainder of 5/12. So I know that to get round the edge of half of this, to go down here and to go along here, it's going to be 6 and 5/12. So I now just need to double that. Instead of 6 and 5/12, if I multiplied that by 2, I would get 12 and 10/12. I don't want to multiply the denominator because that's not actually multiplying it by 2. If I multiply the numerator and the denominator, it would stay equivalent. So I actually want to double it, but it can now simplify and be 5/6. So there we go. My final answer here is 12 and 5/6. Well done if you got that. Amazing. You might have also left it as an improper fraction, 77/6. So if you left it as 77/6, absolutely fine as well. It didn't say what to leave your answer as, so all good if you got either of those or any equivalent fraction to those. Question number 14. A stall sells tea, coffee and hot chocolate in the ratio 3 to 5 to 4. What fraction of the drinks were coffee? So tea, coffee, hot chocolate. The order of the words in the question is the same as the order of the ratio. So I know that this is tea, this is coffee, and this is hot chocolate. What fraction of the drinks were coffee? That's our middle number there. So 5 out of how many parts there were altogether. 3 add 5 add 4 is 12. So 5 out of 12, 1 mark for the numerator, 1 mark for the denominator there. Part B, write 12 to 42 in the form 1 to n. So this just means I want the left-hand side to be 1. And whatever I've done to the left-hand side of my ratio, I need to do the same to the right-hand side to keep it equivalent. Now what I've done is I've divided this side by 12. So I now need to do 42 divided by 12. 42 divided by 12 is quite tricky, but whenever you have a tricky division, I would always encourage you to write it as a fraction because then you can just simplify it. So both of these numbers are even, so let's make it 21 divided by 6. Both of those numbers are in the 3 times table, so let's make it 7/2. We're just simplifying the fraction, and 7 divided by 2 is a lot easier for me to do without a calculator. Half of 7 is 3.5. You can't normally have a decimal in a ratio unless they have specifically said the left-hand side or the right-hand side has to be 1, then the other number is whatever it needs to be in order to make that happen. So your answer is 1 to 3.5 there. Question number 15. Ben wants to buy 41 hats. Each hat costs £5.90. Estimate the total amount of money Ben will need to buy all of the hats. Now, estimating on the non-calculator paper is a really big clue that if we are multiplying or adding or doing some sort of arithmetic, we can round our answers to one significant figure to roughly work out the answer. So instead of buying 41 hats, let's make our life easier and just buy 40. And instead of the cost of the hat being £5.90, we're just going to say that that is £6. So to estimate the total amount of money, I now can do 40 multiplied by 6. 4 times 6 is 24, so 40 times 6 is going to be 10 times bigger, and £240 would be my answer there. For part B, The cost of a hat increases by 20%. Calculate the new cost of a single hat. So each hat is £5.90. And we want to increase that by 20%. Now, 10% of £5.90, to get 10%, we divide by 10. So that's going to be 59p or 0.59, which means that 20% would be double that. So 0.59, add another 0.59 or 0.59 multiplied by 2. 2 times 9 is 18. 2 times 5 is 10. Add the 1 is 11. So 1.18. And that is going to be the increase added on. So £5.90, add £1.18, gets me £7.08. And that is the cost of our new hat. Question number 16. Here are the first 5 terms of an arithmetic sequence. Find an expression in terms of n for the nth term of this sequence. So you may know I use Dino for this, or Dino. The debate is still open about which one to use. It is going to be the difference in front of an n, 1 in front, or the 0th. The difference is 7. We are adding 7 each time, positive 7. So we put the difference in front of an n, so 7n, and 7n would give us the 7 times table. So 1 lot of 7 is 7, 2 lots of 7 is 14, 3 lots of 7 is 21. But I don't want those numbers. I don't want to start on 7, I want to start on 1. And that is going to be 6 smaller. So it's the 7 times table, take away 6. Now I have got a cheat for this, and that is to just get the number that is 1 in front. So it's the difference in front of an n, and then 0th, or 1 in front is how I remember this bit. So 1 in front, if you went back by 7, you would get to -6. And that's going to be a help to find out what the shift is. So 7n minus 6 is the nth term for that. That then enables me to work out any number in the sequence. If I want the 12th number in the sequence, I can say, well, I know that 7n minus 6 is my nth term. I would like the 12th term in the sequence, and to get that, we just make n 12. N is the position number. So we're going to do 7 multiplied by 12, which is 84, and then take away 6 afterwards, which is going to be 78. And 78 would be the 12th term. Now, there is nothing wrong with keeping on going. We had 5 terms here, so you could just keep adding on 7s if you wanted to. It's just slightly inefficient and it will take you a little bit longer, but nothing wrong with that at all. Question number 17. 180 students were asked if they prefer running or cycling. The students were all in year 10 or year 11. The ratio of students in year 10 to year 11 was 4 to 5. 55% of the students preferred cycling, and 4/5 of the year 10 students preferred running. Use this information to complete the frequency tree. So first, let's have a look at the ratio. The ratio of year 10 to year 11 is 4 to 5. So we're going to take the 180 students and we're going to divide them equally over those little lines. 4 add 5 is 9, so we've done 9 little lines altogether. 180 divided by 9 is 20. That tells me that each of these little lines has 20 students on them. So if I want to know how many year 10s there are, I can do 20 multiplied by 4, and that is 80 year 10s. If I want to know how many year 11s there are, 20 multiplied by 5, and that is 100. So 80 year 10s and 100 year 11s, and this here we know is 180 for the starting value. We then are told that 55% of the students preferred cycling and 4/5 of the year 10 students preferred running. So 55% of the students means I'm going to do 55% of 180 because it's of the students. It's not of the year 10s or of the year 11s. 55% of the students preferred cycling. Now to get 10%, we would divide by 10, so that would be 18. To get 5%, we would half that. If you know that 10% is 18, 5% will be half of that, so 9. And then we can do 50%, which would be half, so that would be 90. And then to get 55%, I'm going to take the 90, and I'm going to take the 9, and I'm going to add them together. So 55% of 180 is 99. It's our 50% and our 5% added together. So we know that the cycling circles, this one and this one, need to add together to make 99. But we don't quite have enough information to know which to put in, as how many to put in each yet. But we do know that 4/5 of the year 10 students preferred running. And here we're going to see that fraction of amount skill again. 4/5 of the year 10s, there are 80 year 10s, so 4/5 of 80 is going to tell me how many year 10s preferred running. Now to do a fraction of an amount, we divide by the bottom and multiply by the top. 80 divided by 5, how many 5s go into 80 is 16, and then 16 multiplied by 4. When you're multiplying by 4, you can always double it and double it again. 4 times 6 is 24, and 4 times 1 is 4, add the 2 is 6. So I know that 64 of the year 10s preferred running, so let's put that there, which means that the rest of the year 10s preferred cycling. So if I know it adds up to 80, these two circles will always add to make the number there. I need cycling to be 16, because 64 add 16 adds to make 80, and you can do 80 take away 64 if you want to get that value. More on the floor, borrow from next door. That's how we've got 16. Now we know that the cycling circles need to make 99. So let's now do 99 take away 16, which is 83. That one must be 83. And then again, we know that these two need to add to make 100. So that's going to be 17 in that one there. And that is our frequency tree fully complete. We're then told that one of the year 10 students is chosen at random. Now we are only picking from the year 10s. So this is out of the number of year 10s. We want to write down the probability that this student preferred cycling. So a year 10 that prefers cycling is going to be these 16 students. So 16 is the number of students that we're interested in picking, but we're only choosing from year 10. I think it would be really easy to write 180 here, because you might think it's out of all of the students. And if it said one of the students is picked at random, it would be out of 180. But here we're only picking from one of the year 10s. So it's out of 80, because that's how many year 10s there are. So 16 out of 80 would be your answer there. You can simplify it if you want to, but if it's worth a mark, it will always say, give your answer in its simplest form. And it didn't, and I wouldn't bother for probability. Okay, question number 18. Work out 7.18 multiplied by 3.6. There are two methods here that I would recommend, and I would hugely encourage you to be confident in one of these methods. Which one doesn't really matter. I just need you to have a method. So if we're doing traditional column method, I would want you to make this 718 multiplied by 36. Just take the decimal point out. Let's worry about it after. It's not going to change the digits, okay? So let's just multiply this and we'll worry about the decimal point after. Starting then with the 6. 6 times 8 is 48. 8 carry the 4. 6 times 1 is 6. Add the 4 is 10. And 6 times 7 is 42. Add the 1 is 43. I'm then going to move over to the 3, except it's not really a 3, it's 30. So we need to put a 0 here to hold the place value. 3 times 8 is 24, so 4 carry the 2. 3 times 1 is 3, add the 2 is 5, and 3 times 7 is 21. Adding that together, I've got 8, I've got 4, I've got 8, 4 add 1 is 5, and I've got 2. Oh, you can't see it. And now we need to work out where to put the decimal point. Now, I can do that in a couple of different ways, but the question was 7 times 4, roughly. And if I had to estimate that answer, I would expect the answer to be close to 28. It's a little bit less than 4, a little bit bigger than 7, but the answer needs to be around 28 to make sense. So saying 258 is just way too far away. So I know that this is going to be 25.848 as my answer, because that makes sense. That's a sensible answer to that question. I can also see that there are 3 numbers after the decimal point in the question. So there is going to be 3 numbers after the decimal point in the answer. That way is a bit of a cheat, but that works. So then let's do it the other way. And this is going to be the lattice method or Napier's bones. It's got loads of different names. And I would really encourage you, if you've got to year 11 and you're not confident on that column method, then this is the method for you. I often mark foundation papers, and when I'm marking foundation papers, I find that this method tends to go wrong less often. It's got less carrying. It's a little bit less to remember in your head. So 7.18, that's why I've made this 3 boxes wide, and 3.6 down here, that's why I've made it 2 boxes tall. You're then going to split every single box diagonally from top right to bottom left. And at the bottom, just make it a little bit longer so you've got somewhere to put your answer. Now that genuinely is the hardest part of this topic, is drawing that grid out. Once you've done that, you're laughing. 8 times 3 is 24. 8 times 6 is 48. 1 times 3, so the number at the top multiplied by the number at the side, is just 3. Now when that happens, you're going to put 0, 3, because you want the 3 in the unit side. 1 times 6 is 6, so 0, 6. 7 times 3 is 21, and 7 times 6 is 42. I now need you to add down each diagonal strip. So we're just going to do 8 here. For the next diagonal section, 6 add 4 is 14. So 4, carry the 1. In the next diagonal section, 2 add 3 is 5, add 2 is 7, add 1 is 8. In the next diagonal section, 0 add 1 add 4 is 5, and then we've just got a 2 there. And you can see that we get the same digits, 2, 5, 8, 4, 8. With this method, I'm going to come down with this decimal point and across with this decimal point until they meet. And when you get to that point, you're going to go down the diagonal, and that tells you where to put the decimal point. So 25.848 is your answer. Does not matter which way you did it. Both methods are referenced on the mark scheme. 25.848, and don't go into your non-calculator paper not knowing how to do that, because it's likely that you're going to have to do some sort of arithmetic of that kind. Question number 19. Work out 15.12 divided by 1.8. Now dividing, I've said if it's tricky, write it as a fraction. So I'm going to start by putting 15.12 divided by 1.8. The line in a fraction means divide. So we're dividing by 1.8 here. Now, I don't really want to divide by 1.8. It's quite tricky. So let's divide by 18 instead. That's going to be a much nicer number. If I can make the denominator, if I can make what we're dividing by a whole number, then I'm going to do that. So let's make it 18. Now to do that, I've multiplied the denominator by 10. And we can do that as long as we also multiply the numerator by 10, because that would keep my fraction equivalent. So that's going to be 151.2 divided by 18. And this is now a lot nicer. 151.2 goes inside my bus stop, and we're dividing by 18. Now, if you want to, you could divide by 9 and then by 2. You could divide by 6 and then by 3. That would work, okay? And I think I might do that here. Dividing by 18 is the same as dividing by 9 and then dividing by 2. As long as the two numbers multiply together to make 18. So instead of dividing by 18, you could divide by 6 and then divide by 3. That would work as well. As long as the two numbers multiply to make 18, that's all good. So I'm actually going to do that. I'm going to do my double-decker bus stop here. Divide by 6 and then divide by 3. Why not? So 6 into 1 doesn't go. 6 into 15 is twice remainder 3. And 6 into 31 goes 5 times remainder 1. 6 into 12 goes twice. Now let's have a look at this. 25.2 divided by 3. 3 into 0 doesn't go. 3 into 2 doesn't go. Let's carry those 2 that we haven't used up over. 3 into 25 goes 8 times. That's 24, remainder 1. And 3 into 12 goes 4 times. So your answer here is 8.4. That's your final answer. Now, a lot of the time students will say to me, but you multiplied it by 10. Don't I need to divide it back by 10 at the end? And the answer is no. Because you multiplied the numerator and the denominator, you kept those fractions equivalent. They are the same thing. So all good. That is your answer, 8.4. Okay, question number 20. Write 153 as a product of its prime factors. So 153 at the top And we are doing two numbers that multiply together to make 153. And you might think, well, I don't know what goes into 153. But if I look at the digits, 1 add 5 add 3 is 9. If the digits add up to a number in the 3 times table, then it's in the 3 times table. So let's just go over here and do our bus stop. 153 divided by 3. 3 into 15 goes 5 times, and 3 into 3 goes once. So this is 3 times 51. And 51 feels like a prime number, but it isn't. Again, 5 add 1 is 6. So we know it's also in the 3 times table. So let's do 51 divided by 3. 3 into 5 goes once, remainder 2. And 3 into 21 is 7. So this is also in the 3 times table. 3 times 17. We circle a number if it is prime. Your prime numbers are numbers that are only divisible by 1 and themselves to give a whole number answer. We've only got 2 factors. They're only in the 1 times table and their own times table. The first prime number is 2, then 3, then 5, then 7, then 11, not 9 because it's in the 3 times table, then 13, 17, and so on, okay? So those are all my prime numbers. Once you've completed your tree, don't put commas in between. I see it so often, this, 3, 3, no, don't do it, right? It is the product of their prime factors, and product means to multiply. So 3 times 17, except I said, give your answer in index form. So that would be 3, oh, I'm highlighting it now. That would be 3 squared times 17. The index form means to use the indice. Oh, there we go. 3 squared times 17 would be your final answer. We're then asked to find the lowest common multiple of 102 and 153. Now, we already know that 153 is 3 times 17. We just worked that out in the top bit. So let's now do the prime factorisation for 102. That is 51 times 2. And again, we know that that's 17 times 3. Let's do our Venn diagram. This circle is going to be for 102. And this circle is going to be for 153. And we need to worry about what we can put in the middle. What do they both have? So 102 is 2 times 3 times 17. So we can put a 3 in the middle. They both have that. And we can put a 17 in the middle. They both have that. 102 has 2 left over, and 153 has 3 left over. If I want the highest common factor, it's the numbers in the intersection multiplied together. So 17 times 3 is 51. If you want the lowest common multiple, you're then going to take that 51 and multiply it by any numbers left on the outside. 51 multiplied by 2 multiplied by 3. So 51 times 2 is 102. And I'm then going to multiply that by 3, which is 306. So that would be my lowest common multiple, the first number that's in both of their times tables. Now, you may have just written out the 102 times table and written out the 153 times table. That absolutely works as well. So if you did it that way, make sure you've got 3 multiples of each before you write your answer on the answer line. That would be a really good idea, or until you get obviously to 1 of each and you get your answer of 306. Okay, question number 21. It takes 5 workers 15 days to build a house extension. How long would it take 3 workers to build the same extension? So this is an example of proportion, and we need to think very carefully about whether it's direct proportion or inverse proportion. Now, direct is like if I buy 1 chocolate bar and it's 50p, and I buy 2 chocolate bars and it's £1, 3 chocolate bars it's £1.50. As the cost goes up, the number of chocolate bars goes up, they are directly proportional. Inverse proportion means as one thing goes up, the other one comes down. So if it takes 5 workers 15 days, so 5 workers equals 15 days, it's always a good idea with these questions to think about 1 worker or 1 of whatever it is. If I only had 1 worker, then I've divided the number of workers by 5. A lot of students would divide the time by 5. However, think about what this means. If I've only got 1 person building the extension, it's not going to take less time, it's going to take more time. So as you've got more workers, it would take less time. And if you've got less workers, it would take more time. So this is an example of inverse proportion. As one goes up, the other one goes down. So if we've divided the number of workers by 5, we're going to multiply the number of days by 5. 15 times 5 is 75. Now we've got 3 workers. So if I've now multiplied the number of workers by 3, I'm going to divide the amount of time by 3, and 75 divided by 3 is 25 days. State one assumption you made in working out your answer to part A. So the assumption that we made is that all of these workers are just as good as each other. One of them might be a little bit lazy, and that might affect our answer. So we're going to assume that all the workers worked at the same pace. Or none of them are lazy. Something like that. Okay, question number 22. There are only pink cubes, grey cubes, and white cubes in a box. The table shows the probability of taking at random each colour of cube from the box. So the probability of taking pink is X, the probability of taking grey is Y, and the probability of taking white is Y. It then says that the ratio X to Y is 2 to 1. So we know that whatever the probability of X is, it's double the probability of Y. Now, that is a little bit tricky to get your head around the way that that's written, but Edexcel seem to like giving it to you like this more and more often. So it might help if you just change it to be 2A, A, and A. We know that whatever pink is, that probability is double the other two, and the other two are the same. So 2A, A, and A, you might find that helpful, or you could make this one 2Y if you want, because it's double. Either way, if we add it together, we get 4A or 4Y, and we know that that is 1. It has to add up to 1. Probability always adds up to 1, and there are only pink, grey, and white cubes in the box. If 4A equals 1, then A equals a quarter, 1 divided by 4. So I now know that this one is 0.25, this one is 0.25, and therefore the X is double, that one is 0.5. Work out the probability of Y, the value of Y, the value of Y is 0.25. Question number 23, and we have standard form. Write 0.00209 in standard form. To write a number in standard form, we need to use a number between 1 and 10 times 10 to the power of something. So the digits here that I need are 2.09. Those are the digits that we need for this question. And we need to multiply it by 10 to the power of something. Now, if the number is smaller, we're dividing by 10. To achieve that, we still write times by 10, but the power needs to be negative. So if I've got 0.00209, I want the decimal point to fall in between the 2 and the 0. Now, really, we're moving the numbers, but it's far easier to move the decimal point when we do this. So 1, 2, 3 times it needs to be divided by 10. So that's the same as 2.09 times 10 to the power of -3 for that one. For part B, we're asked to go the other way. We need to do 1.302 times 10 to the power of 4. So times it by 10 once, times it by 10 again, times it by 10 again, and times it by 10 again. 1.302 times by 10, times by 10, times by 10, times by 10. So first it's going to be 13.02, then it's going to be 130.2, then it's going to be 1,302, and then it's going to be 13,020. 13020 for the mark there. Question number 24. A, B, C, D, E, F is a regular hexagon. Work out the size of angle X. If it is a regular hexagon, then we know that all of the angles inside the shape, not the ones that have been chopped up, but all of the angles like these ones are going to be the same. And we know to get the total number of degrees inside a polygon, we do the number of sides, take away 2, multiplied by 180. If it is a 6-sided shape, a hexagon, 6 take away 2 is 4. So 4 times 180, and 180 multiplied by 4, 4 times 0 is 0, 4 times 8 is 32, and 4 times 1 is 4, add the 3 is 7. So all inside this, inside this polygon, that angle, that angle, that angle, that angle, that angle, and that angle adds up to 720. And because it's a hexagon, if I want one of them, I can do 720 divided by 6, because there are 6 angles inside a hexagon. 6 into 7 goes once, remainder 1. 6 into 12 goes twice. And 6 into 0 goes 0 times. So I know that this is 120. I know that this is 120. I know that this is 120. And I know that this is 120. This is 120, and so on, okay? So all of these are 120. From there, I'm going to look over at the trapezium, and I can see that this is a quadrilateral. And so the angles inside this shape add up to 360. Because this length is the same as this length, and 120, 120 are the same angle, we know that this angle here is going to be the same as this angle here. 360 degrees in a four-sided shape minus 120 and 120, so minus 240, we are left with 120. And 120 then needs to get split equally between the two angles. So 60 degrees here and 60 degrees here. If this angle is 120 degrees in total, and I've got 60 on that side, 120 take away 60 leaves us with 60 degrees, which is going to be my answer for x. Question number 25, complete the table of values for y equals 5 minus 2x. So for each of these x values, I need to substitute it into that equation. We know to get y, you need to do 5, take away 2 lots of the x value. So in this case, minus 1. 2 lots of minus 1 is minus 2. So I'm doing 5 minus, and then this bit is minus 2. So 5 minus minus 2, that's going to turn into an add, and that's going to be 7. For the next one, 5 minus 2 lots of 0. 2 lots of 0 is 0. 5 take 0 is 5. Then for the next one, 5 take away 2 lots of 1. 5 take away 2 is 3. For the next one, 5 take away 2 lots of 2 is 5 take away 4, which is 1. And last but not least, 5 take away 2 lots of 3, and that is 5 take away 6, so minus 1. I then have each of the coordinates to plot on my graph. So minus 1, 7 is up here, 0, 5 is here, 1, 3 is here, 2, 1 is here, and 3, minus 1 is like that. I'm going to get our ruler and join it up with a nice straight line, she says. There we go, a nice straight line looking like that. Now we can look at two things on that graph. I can see that the y-intercept is 5, and I can see that the gradient is minus 2, because every time we went across by 1, it went down by 2. So 1 across minus 2 means that the gradient is minus 2. The gradient is, for every 1 across, what happens to the line. We're then asked to give the equation of a line parallel to that one. If a line is parallel to that one, it's going to have the same gradient. So y equals minus 2x, add 3, or y equals 3 minus 2x, or y equals minus 2x, add 7. The number in front of x needs to be minus 2. It needs to be y equals minus 2 lots of x, and then another number. You don't even have to write another number, to be honest. You could have had y equals minus 2x. That would go through the origin, because it would be plus 0. So it doesn't matter what the other number is, your y-intercept, it would be parallel here, or that's not parallel. It'd be parallel if it was down here. It'd be parallel if it was up here. It wouldn't make any difference, the y-intercept, but we need to make sure that we see that negative 2 in front of the x and y equals to know that it's the equation of the line. Question number 26. Expand the bracket. So to expand a bracket, we're doing what's on the outside multiplied by the first thing and what's on the outside multiplied by the second thing. So this is going to be 2x squared minus 5x. X times 2x is 2x squared. X times minus 5 is minus 5x. They are not like terms. You cannot do anything with that. That is your answer, 2x squared minus 5x. For part B, we're asked to factorise fully. Factorise means to put into brackets. What have they got in common? Now, the factorise fully is a clue that more than one thing is going to come outside the bracket here. Both 15 and 21 are in the 3 times table, and both terms have k as a factor. So we can bring 3k outside the bracket. What would we need to multiply the 3k by to get 15k squared? Well, we need to multiply it by 5, but also by k, because the k multiplied by the k gives us k squared. Then subtract, and now we need to think about 3k multiplied by something that makes 21k, and that is going to be 7. So 3k brackets 5k minus 7 is your answer there. If you only brought the 3 out and left it as 5k squared minus 7k, that would get you 1 mark. If you only brought the k out and you left it as 15k minus 21 inside the bracket, then again, you would only get 1 mark. It needs to be correct to get 1 mark, but you might not have brought both terms outside. For part C, we're solving an inequality. You guys know whether it's an equals or an inequality, whether it's an equation or an inequality, we need to put that dotted line where the equals sign or where the inequality symbol is, and what we do to one side, we're going to do to the other. I'm going to start though by expanding the bracket. 4y add 8, so 4 lots of y, 4 lots of 2, is less than 22. We're then going to take 8 away from both sides to get rid of it. We're trying to get the y on its own. That's the aim of the game. 22 take away 8 is 14. And then we're going to divide both sides by 4. So dividing by 4 is halving and halving again. So I'm left with y is less than, and you can leave it as 14 over 4 if you want to. That is perfectly acceptable. It doesn't go in an exact number of times, so that would be okay. But I'm going to half it and half it again. Half of 14 is 7, and half of 7 is 3.5. So y is less than 3.5, and you need to make sure that inequality symbol is in your answer. You can't just put 3.5 on the answer line. It's not an equation, it's an inequality, so it's important that y is less than 3.5. Question number 27. Alice travels 45 miles in 90 minutes. What was Alice's average speed? So we know that speed is distance divided by time. You might remember this triangle. So if you want the speed, cover that up and do the sum that's left behind. Distance divided by time. Now the distance is 45, but the time is 90. So 45 divided by 90 gives you a half. 45 over 90 is a half. But that speed is in miles per minute. You did the number of miles divided by the number of minutes. So Alice goes at half a mile a minute. So in 60 minutes, which is a full hour, we're going to times by 60, a half times 60, she would be able to go 30 miles an hour. Now that's one way of working that out. Another way of working out these questions is to use a little bit of common sense. If Alice goes 45 miles in 90 minutes, then let's look at this, they're both divisible by 9. So let's do 5 miles in 10 minutes is how far she'd go. But we know that the speed needs to be in miles per hour. So actually, let's think about 60 minutes. How far would she go? I've multiplied that by 6. So I also need to multiply this by 6. So she would go 30 miles in 60 minutes, which is 30 miles per hour. And last but not least, question number 28, and this is SOHCAHTOA, trigonometry. So first thing I'm going to do is label my sides. I know that this is the hypotenuse, I know that this is the opposite, and I know that this is the adjacent. And always with SOHCAHTOA, let's do the triangles over here, SO, CA, and TOA. And with these, we need to work out what we want to be involved. I know that the opposite needs to be involved because I know it, it's helpful information. The hypotenuse needs to be involved because that's the thing we're trying to work out. I don't know how long the adjacent is and I don't want to work that out. That's not involved in this question. So O and H being involved tells me to use SO. This one was the hypotenuse, by the way, because it was over from the right angle. And then you need to imagine you're stood in the other interesting angle. Whichever side is opposite you is the opposite. Whichever side is next to you between the two angles, that is your adjacent. Perfect, but we didn't need that one. So there we go. O and H, we're going to use SO. Now, we want the hypotenuse. So cover up the H and do the sum that's left behind, which is O divided by S. O is the opposite, so 14. And we're going to divide that by S, which is sine 30. If we were using CA, it would be cos 30. If we were using TOA, it would be tan 30. So this is what we've got to do. And you might be thinking, but I don't have a calculator. This is a non-calculator paper. And you are expected to know the value of sine 30, and you're expected to know that sine 30 is a half. If in doubt, if you can't remember what they are, if you haven't learnt your exact values, guess a half. I was going to say it's probably going to be a half, but it's a good guess. It's better to have a guess at half than nothing at all. So 14 divided by a half is the same as 14 multiplied by 2, because when we divide by a fraction, it's the same as multiplying by its reciprocal. We saw that earlier on. So 14 times by 2 is 28. So your answer for that question is 28. If you think about 14 pieces of paper, if I asked you to divide them all into halves, there would be 28 pieces of paper at the end. So there we go. I hope you found that helpful. Please let me know in the comments if you want any further clarification or resources on any more of the topics, or what topic is that called, things like that. I would be absolutely happy to help. I hope you enjoyed it, and I hope you feel more prepared for your exams. Thank you so much, and I will see you on the next one.